In this video lesson, we're going to briefly talk about valence bond theory. Up until now, we've been looking at atoms bonding together in Lewis dot structures as well as molecular geometry. And although we've been talking briefly about why atoms bond with regards to the octet rule, we really haven't been going into too much depth as to how this happens or what it looks like. There's a lot of different bonding theories out there, and valence bond theory is one of them. Now, we're not going to go too much into depth with it, but it is a good idea to be familiar with what valence bond theory is actually saying. So the definition of valence bond theory, or basically what its main postulate is that atoms are going to come together and bond, or in other words, atoms are going to share electrons when an atomic orbital on one atom overlaps with an atomic orbital on the other. So let's take a look at a few examples. Let's first take a look at the hydrogen molecule, or H2, which is located down here in the bottom left. Before we explain valence bond theory, let's go ahead and go over the color scheme a little bit, because this will be something you'll see later on. You'll notice that the two hydrogen atoms before they are bonded is kind of like this light or translucent yellow, whereas when they come together, they're a darker yellow. The translucent yellow represents the hydrogens as being not fully filled with electrons. To understand this, let's take a look at the electron configurations for hydrogen. Let me make this screen a little bit smaller so we can see that. Okay, so if we think about what the electron configuration for a hydrogen atom is, it's 1s1. In other words, that's basically saying in the 1s orbital, let me give myself some more space here. There we go. In the 1s orbital, there happens to be one electron. And obviously, since there's two hydrogens, this would be the electron configuration for the other hydrogen, and it would look the same. So you can see that the hydrogen electron configuration on the left and the hydrogen electron configuration on the right are both half filled. This one has one electron, this one has one electron. That's why they're both that translucent yellow. When they come together and overlap, or in other words, in the middle where they bond, it's this half-filled orbital and this half-filled orbital that are coming together and bonding to both share the one electron and one electron, making it two in the middle. Let's take a look at another example. Let's take a look at one in which there's a p orbital. For example, the fluorine molecule. Okay, the fluorine molecule, or F2, is a result of the overlapping of the orbitals in the fluorine atom. So let's take a look at what the fluorine looks like in its electron configuration. All right, so here are two separate fluorine atoms. They haven't bonded yet. And you see here at the bottom, these are the the orbital diagrams for the two fluorines. Now, since they're both fluorine, obviously they look the same. So the electron configuration for the first fluorine is 2s2, 2p5, and notice how it's filled. And then the second fluorine, being the same element, obviously, has the same configuration. You'll notice here that this fluorine has space for one bonding site because it has the one half-filled orbital here. The second fluorine obviously has the same thing. So if you take a look at the picture up here showing those orbitals, you'll notice that it has the three p orbitals overlapping. You have the py, you have the pz, and then you have the px. Two of the three p orbitals are kind of that dark blue or dark purple color. You see this one right here and this one right here. That represents the two orbitals that are completely filled with electrons. Same thing on the other fluorine. That represents the two orbitals that are filled with electrons. So that, in other words, is saying there really can't be any bonding with those p orbitals. However, the third orbital, which you see lying along the x-axis there, is that translucent color, indicating that it's not completely filled, or in other words, it's only half filled. And that would represent the half-filled orbital that you see here that only contains the one electron. Because the two fluorine atoms have space for those to overlap, in other words, this has one bonding site and this has one bonding site, these two half-filled orbitals would come together and overlap, therefore sharing the electrons, and that way, when that happens, notice how the orbitals become darker purple or darker blue, indicating that now they're filled because they're sharing those electrons. Another thing I want you to notice, if you haven't noticed already, is that when we're referring to s orbitals, s is indicated with yellow. When we're referring to p orbitals, p is indicated with that bluish purple color. Okay, so what's really the main thing I need you to get out of valence bond theory? Because we're not going to go too in depth. Valence bond theory is explaining why atoms are sharing electrons. Basically, that happens when they have overlapping of orbitals. So, for example, you see down here again, completely different example, but same thing applies. When you have the hydrogen and the fluorine unbonded, you can see they have that translucent color, indicating that this hydrogen has one unshared electron, or unpaired, I should say, one unpaired electron, and this fluorine also has the same thing. When they bond, those orbitals are overlapping, and therefore that's why they now feel like they have filled orbitals. What happens when a bond takes place is that the energy resulting when the molecule forms is actually lower than the combined energy of the isolated atoms. So think about the energy of a hydrogen atom when it's uncombined and the energy of a fluorine atom uncombined. If you take those two energies combined together, they're higher than if they were bonded together. This explains why atoms want to bond, because their energies, when they bond together, are lower than when they were unbonded. Okay, so in other words, that's basically saying when bonds are formed, energy is given off, because the energy that is resulting when they bond is lower than the energies than when they were unbonded. In order to have a lower energy than before, it must have given off some sort of energy in the process. So when bonds form, energy is given off. And the reverse of that is also true. If you want to break the bond, you're going to have to put energy in order to break that bond. The other thing I want you to get out of valence bond theory that I've already described is that when the orbitals are only half filled, it's that translucent color. When they overlap to make a bond, that's where their color is going to change. And really, that's all we need to go into with valence bond theory. But valence bond theory it does have its limitations. It's not entirely accurate. However, it does help us qualitatively analyze bonds. And it's actually going to help us in the next video, which is all on hybridization.